All right, hey pre-calculus, let's start at question 7. I just did a video on questions 1 through 6, so watch that first if you haven't seen that already. All right, looking at question 7, I'm multiplying a rational expression. In order to do question 7, you got to be really good at factoring, okay? So to start, you need to know the difference of squares. If you don't know what difference of squares is, go look at some practice on difference of squares. All right, and we're going to start with difference of squares to be able to break down x squared minus 16, and we can break that down into x plus 4 and x minus 4. Okay, so I've broken down my x squared minus 16. Let's leave our denominator alone for right now, 9 minus x. All right, moving over, notice I've got a trinomial. That means I've got 3 terms, okay? Just like I taught y'all in the previous video, when you've got 3 terms, that means you need to use the x method, okay? So I've got the x method, x squared plus x minus 90. In other words, I'm looking for 2 numbers that are going to multiply to negative 90 and add to 1. Well, the only numbers that I know that are going to do that, let's see, that's going to be negative 9 and positive 10. So I'll use those as my factors. So x minus 9 times x plus 10. Awesome. All right, all over x squared plus 14x plus 40. I'll use the same x method to keep breaking this thing down. So one more time, the x method. A times c goes up top, so in that case that's 40. B for bottom is 14. And I'm looking for 2 numbers that multiply to 40 and add to 14. So in our case, let's see, what are those numbers going to be? How about 4 and 10? That sounds good. Let's do 4 and 10. So positive 4 and positive 10. So x plus 4, x plus 10. Really, y'all, that's the hard part about this question. Once you're here, you're smooth sailing, I promise. So if you can get through that factoring, you're good. All right, check it out. Let's look at what things cancel out. I'm going to switch to my black pen now. All right. So I'm looking for things that we see both in the numerator and in the denominator. All right, so that's kind of our goal here. All right, so I see x plus 10 in the numerator denominator. So let's cancel them out. Awesome. I notice x plus 4 in the numerator and the denominator here. Let's cancel those out. And it's a little bit sneaky, but do you notice x minus 9 and 9 minus x? We can actually rewrite this 9 minus x right here. Look at this. I can rewrite this as negative. I can rewrite that term as negative x minus 9. Okay, the reason that was so helpful to us is now we see again something else we can cancel out. I see an x minus 9 in the denominator and in the numerator. So let's cancel that out. And be very careful, what are we left with? Well, we're left with the x minus 4 in the numerator, and we're left with, looks like, a negative in the denominator. So our final answer here is going to be negative x minus 4. Let me write that a little bit clearer. Negative x minus 4. That's the only 2 pieces that are left of this. So once you factor, you cancel out, and you're done. That's how to do question 7. All right, let's move on. All right, cool. Let's take a look at question number 8 here, y'all. It says add the rational expression and then write in simplest form. So kind of similar to some of the questions we did on the previous video, we need to have a common denominator to do this. So look back to that in case you're curious for what I'm talking about. Before we jump into the common denominator, let's go ahead and do just a little bit of simplification, make our life easier. So 5 over n plus 5, there's nothing I can really do there. But I can simplify this 4n over 2n plus 6. So let's go ahead and do that. So I can simplify this because I can factor out or divide out by 2 in my denominator here. And I'm left with n plus 3. So 2 times n plus 3. This is helpful to us because we can simplify a little bit. I've got 4 up top, 2 at the bottom, and so the question I would pose to the class is, hey, what's 4 divided by 2? Well, it's just going to give us 2, right? So let's go ahead and write this piece right here in simplified form. So I'm left with 2n over n plus 3. All right, so that's my simplified piece of this fraction right here. All right, great. So now we can rewrite sort of the question that we're being asked. 5 over n plus 5 plus 2n over n plus 3. And so again, like I showed y'all in the previous videos, you need to get the common denominator. In this case, I'm going to use something that's a combination of both of our denominators here, n plus 5 and n plus 3. Essentially what I'm going to do is I'm going to multiply this fraction right here by n plus 3, and I'm going to multiply my fraction on the right by n plus 5. That way they have a common denominator. So let's go ahead and do that. And so I'll write the math that I'm doing here. I'm multiplying this piece by n plus 3 over n plus 3. And on the right-hand side, I'm multiplying by n plus 5. This says n plus 5 here. I don't know what happened there. All right, so we've multiplied on our left by n plus 3, on our right by n plus 5. I'm going to go ahead and erase this and sort of write what we get once we do that multiplication. So take a minute to go ahead and do that multiplication. Whew. Wow, okay. That was a lot of work. So all I did was I just multiplied my function, my fraction on the left by n plus 3. So that's why I see n plus 3 there. And on the right by n plus 5. And so now we have a common denominator. Our denominators are the same. And so we can simply add across the top here. And if we add across the top here, let's write what we get. So I'll write that just below. All right, so I've got 5 times n plus 3 plus 2n times n plus 5 all over our common denominator there. All right, that puts us in a pretty good position, but we're not quite done. In order for us to finish what we've got here, we do need to simplify what we've got up here in the numerator. And so the way that we're going to do that is we're simply going to distribute. So let me draw in some black arrows to denote what I'm going to distribute so y'all can see how to get to the next step. When I say distribute, I mean multiply it. 5 times n, 5 times 3. And then over here, we'll need to distribute the 2n to the n plus 5. Okay, wonderful. So I'm going to go ahead and erase and write what happens after I distribute everything up there in the numerator, because I just don't have any more space here. All right, cool. So now I've got my numerator rewritten after I've distributed all of my key terms, and I've got my common denominator. And so my final step of work here to do is I simply need to combine my like terms up top. And so up top, in this case, that's 5n and 10n. And if y'all hear some noise, that's Miss Lynch just coming in, so everybody can say hi to Miss Lynch. Miss Lynch, I'm recording. I'm on question 8.
Question 8 already. That's
Question
crazy.
8 already. All right, so let's go ahead and simplify here, and we're going to write in standard form with our highest exponents first. And so our final answer here will be 2n squared plus 15n plus 15 all over n plus 5 times n plus 3. And so that's what I'm looking for a final answer. This question's about as long as it gets. Go ahead and circle that. That's our final answer. All right, let's move on to question number 9. All right, question number 9, much shorter. So question 9 says, given the graph below, find the domain of the function. So remember, y'all, the domain of our function, those are our x values going from left to right. And so in the case of number 9, if I'm thinking about my domain being from left to right, well, starting on the left-hand side here, the leftmost value of my function here looks like it's at 5. Okay, so my domain is going to start at 5. And as you can see, it continues on infinitely far towards infinity. So 5 to infinity is our domain. Remember, domain is our x values. Moving on to the second question, find the range of the same function. Remember, y'all, that range means y values, so from bottom to top. So now looking at our y-axis here. And so as y'all can see, in the case of our function here, it starts at a y value of 0. That's the lowest y value. And then our highest y value, you can see this function continues both infinitely far to the right and up. And so 0 to infinity is going to be our range here, 0 to infinity. So that's 9 and 10. Let's move on. All right, number 11 says, what is the parent function graphed below? So in this case, it's just a matter of knowing your parent functions. And so for a question like number 11, that is the absolute value of x. That's what the absolute value of x looks like. Moving on to number 12, another question about parent values. Which of the following transformations from its parent function? And so from what we can see right here, this is the parent function of x squared. Okay, one of the first parent functions you probably learned about. And I'll actually draw what the original parent function looks like. So that's what the original parent function looks like right there. Okay, it started at 0, 0, and some shifts have occurred to get it from its original parent function to its new place here. And so it's asking us what those shifts are. Well, the first shift that I'm seeing is that it is moving starting at 0, and it's moving over 4 places to the right. So notice it's shifted right 4. Notice that it's now shifted down 2. It's now, the parabola is starting at -2, so it's down 2. And notice that it was originally facing up like this. Now it's facing down like this. So it's been flipped. It's been reflected over the x-axis here. Okay? So right 4, down 2, reflect over x-axis. So those are the 3 pieces I would need for a correct answer here for number 12. Let's move on. All right, question 13, the graph of f of x equals x to the third is shifted right 3, down 4, and over the x-axis. What equation represents these 3 transformations? Okay, let's do it. All right, so to start with, that first piece, shifted right 3, that's going to be minus 3 inside the parentheses. Okay, and it's to the third power. That's our original function, so x minus 3 to the third. I've taken care of my right 3. Then it says down 4. Well, to do that, I'll go minus 4. Okay, I've taken care of the down now. And then it says reflected over the x-axis. Okay, that means I need to add a negative to our function. So I'll go ahead and add a negative up front. That will reflect over the x-axis, and we are done here. Let's move on to question 14. It says the function g of x equals 2/3 times the square root of x. Which of the following transformations from its parent function? So in this case, its parent function, when we say parent function, we mean the original function. So the parent function in this case is the square root of x. And what has happened to it is it's been multiplied by 2/3. And so back when we taught y'all about the shifts, we also taught y'all about vertical stretching versus vertical shrinking. And so this is a good example of when we would have some shrinkage. So in this case, it would vertically shrink by 2/3. And if you want to go back to your notes and look at the difference between vertical shrink versus vertical stretch, long story short, you have a vertical shrink anytime you've got a value between 0 and 1. So anything between 0 and 1 is a shrink. Anything greater than 1 would be a vertical stretch, okay? So in this case, 2/3, that's less than 1, so it's shrinking. All right, let's keep it going here. Actually cut it off right there.